Hi guys, I'm Jessalyn Duran, and for today's video, I'm gonna do the normalization of database using the hospital record by formulating the 1NF to the 4NF of the database. Normalization, guys, is the process of minimizing the redundancy from a relation or set of relations. So, it is important to eliminate or reduce the redundancy in a database tables because it can cause insertion anomaly, which happens when the data can't be inserted into a database due to other missing data. And it can also cause deletion anomaly, which is the unintended loss of data due to the deletion of other data. And the update anomaly, which is the difficulty to update the data in the table because if you want to change something, you have to update the entire row of it. So now, here's the unnormalized form or the UNF of the hospital record. Now, first rule of 1NF is each cell must be single valued, meaning there should be one entry only for each one cell. As you can see in the UNF, only the patient name and the room number are single valued among the others. The second rule states that the entries in a column must be of the same type. In this case, there's no medicine such as less of fat, and fat burner is not a generic name. Now, the last rule in 1NF is there should be a unique identifier. So, I'm just gonna add patient ID as the primary key or unique identifier. So, there it is, our first normalized form or 1NF that is single valued, same type, and has unique identifier. In 2NF, all non-key attributes must be dependent on the key attribute. So in this case, we have to determine first what is dependent or not on the patient ID. So patient name, yes. Room number also yes, because you can ask where is patient 136A. Oh, in room 102. So the rest is not that dependent on patient ID, and because of that, we have to make another table for them and of course another primary key. So here's the first table in 2NF that contains patient ID as primary key, patient name and room number, followed by the second table which the procedure is the primary key, then the doctor column that contains which doctor should do the procedure, and their background which is the doctor specialization. Then there's also a third table which contains the medicine, its generic name, and its unit price. Now, how will we know what procedure the patient will undergo and what will be their medicine after? In this case, we have to make another table for that, and since they are all primary key and are dependent to each other, this table will have a composite primary key, meaning there are two or more primary key in the table. Moving on, we're now in the third normalization form or 3NF. So here all the fields can be determined only by the key in the table and no other columns. In our 2NF, we have this table that contains procedure, doctor, and doctor specialization. And since doctor specialization can only be determined by the doctor's column, we will remove it and make another table where the doctor is the primary key along with the doctor specialization. Now, what will happen in the previous table? Since we only remove the doctor specialization column, the doctor column is still there also because it was determined by the primary key as which doctor will perform the procedure. But since it was already a primary key of another table, it will be set as foreign key. After that, we just have to copy the other tables and add the doctor in the table that has composite primary key. The last normalized form or the 4NF has only one rule. It is to have no multi-valued dependencies. Since we already sorted that, we just have to copy again all the tables and put a label on it. So there you go, we have the patient information, the procedure information, the doctor's information, the medicine information, and the normalized hospital record. And that's how we normalize a hospital record from this to this. Once again, I'm Jessalyn Duran from 20 BSIS 1M, and I hope you enjoyed my video. Thank you!